Welcome to this webinar on how to monitor model performance in Azure. I'm your host, Wiljan. I'm one of the co-founders of nannyML. The goal for this webinar actually is to fully set you up to run nannyML Cloud within Azure and within your own cloud environment. And after this webinar, you should be able to participate in our trial. All of our offerings, also the ones on Azure, they have a 1-month free trial where you can just spin up an instance and use it however you'd like and test out the product to its full capabilities. And what we will be doing in this webinar is prepare you for that so that you can do it without any support, of course, if you need, always happy to. And also with minimal documentation, but that you can just do it frictionless. And the way we're going to go about that is that we'll first explain how to launch a nannyML instance on Azure. I'll show you how to add a model via the user interface. We'll do a little bit of analysis on a model without target data. Then I'll show you how the SDK works, which is really a Python library to do continuous monitoring, and that's the main way to interact actually with nannyML Cloud. And I'll end with some analysis on the same model, but when the target data is there. So let's get started. I'm going to start from the Azure portal, and then I'm going to go to the marketplace, and I'm going to search for a nannyML. And we have two offerings on the cloud marketplace. One is a SaaS, and the other one is a managed application. And with the SaaS, you as a customer, you would send us data, and then we would do the processing on in our environment, on our resources. And with the managed application, no data leaves your environment, and you basically fetch the software from Azure and you deploy the software within your cloud environment. So I'm going to be picking this one. And then Azure, of course, takes care of the security, the billing, the invoicing, and you can also spend your Azure credits after the free trial on a certain plan. I'm going to pick here the enterprise plan because that comes with some support. We have a data science success program, an onboarding program, and continued support. And then when I'm going to create quickly a new resource group, just for this demo, application name, nannyML. Then I have to look at the infrastructure here too. I'm going to call that my nannyML too. For authentication, there's a few options. We can pick the basic authentication, which is basically the authentication that we provide out of the box, but you can also do the Azure authentication. I'm just going to pick none just for the purpose of this demo. Then for notifications, you can pick the default one where we have a third-party tool set up that sends you emails, but you can also connect to your own email server. I'm just going to pick none here. And then there's just-in-time access. If there are some issues with the managed application running into your cloud, you can give us just-in-time access, and then one of our engineers can look at the Kubernetes cluster and see what went wrong, very low level. I'm just going to say no, and then I can review, and I think it's still loading some things here. And then I should be able, to agree, and then I'm going to create this. And this is going to spin up a managed application within my cloud environment. But I will be revisiting this later because this is going to take some time because there's a Kubernetes cluster that has to be provisioned. So in the meantime, I will just go to nannyML instance that's already being set up and in which there's already some models being uploaded. But before I'll explain this, I'm just going to walk you through on how to add a model via the interface. And I've prepared some data, and this is a binary classification task, and I'm just going to pick accuracy as our main performance metric. We're going to aggregate the results monthly, and the data set is a Kaggle one, and it's called Hotel Booking Data Set. And since we're on Azure, I'm just going to upload via Azure Blob Storage. My account name is nannyML. I have to find the blob storage container though. So I'm going to quickly go to that. And here's hotel booking. I'm first going to select the reference data here. There we go. And then I also need the blob storage container name, which is this one. There we go. And the reference data, it's the same as in open source, where basically we pick a period where we know that the model is behaving as expected. This might be the first months of production when we do high alert, or this ideally is the test set, because that's also the purpose of the test set, that it is created in such a way where we know that everything is working as it should. And then we use that to calibrate our algorithms to derive thresholds from, and it is basically the golden data set to which we will compare our model in production, our performance, our drift. And I'm also going to add quickly an account key, and then we can go to the next step. Then nannyML reads some of that data in, and then we'll have to set up the schema. This is basically what's in the data set. We have to define the target column, and the target column here is canceled, and it's basically whether a booking is canceled or will be canceled in the future. We predict very far along the future. And I also have to set an identifier. And then here the prediction column and the prediction score column, they're already automatically extracted by nannyML. Same for the features inside of the data set. nannyML does some extrapolation to figure out what the data type is. So just quick sanity check, and then I can move on to upload the analysis data. And this is the production data. So these are the model inputs and the model outputs that happen after the model has been deployed. And this is really our data set of interest where we want to carry on an analysis out. So this is a production data. And I'm going to do next. And then I'm going to continue without targets for this first part of the demo, because we're predicting whether a customer will cancel their booking. And this is an event that happens in the future. So right now we're just making predictions, and we don't know yet whether the customers actually ended up canceling or not. And that way we don't have access to targets now. They will come in later. And that's also the bread and butter of nannyML, to deal with those types of use cases where the targets are very much delayed. While nannyML is running here, I'm going to go back to the model overview. We can see this little thing in monitoring status that this new data set is being added, and that we're still waiting for the results. And a very important thing here that we can see, because these are all of the models that we're currently monitoring. And these are some data sets from Kaggle as well, and UCI, just open data sets. And here, this one is the main performance metric. So like we just defined accuracy. And we can see, because it's all green, that for these models, it's all okay. And we have realized performance and estimated performance. We estimate it when the realized performance is not available yet, but for most of these use cases, we have actual targets, so we can measure the realized performance. And only when there is an issue with the main performance metric, we can delve into the other performance metrics that are subordinate, or do a root cause analysis where we can leverage concept shift detection or covariate shift detection and data quality checks to actually see low level, what is it that caused a performance issue. And one very important thing here, and that's also actually the main value of nannyML, is that we see here in this table that for these models, there's actually lots of covariate shift. But since the main performance metric is not impacted by that covariate shift, we don't have to go and delve in deeper here. We would also not get an alert for it, because it's covariate shift that is not impacting the performance. And this happens very, very often. And you can look at it from the perspective that there's unimportant features that are drifting, or that the data shift is happening to regions where the model is still fairly certain. And then it would not impact the performance. And from a data science perspective, then the model can actually just deal with that covariate shift, and then we would not be interested in investigating any further. Let me quickly check if in the meantime Yeah, so in the meantime, this data set has been processed. And we see here our main performance metric, which was accuracy. Here is the reference performance, so the performance on the test set. And this performance is being used to derive these thresholds automatically. And then we can see here in production the expected accuracy or the estimated accuracy by one of our algorithms, MCVPE. So this is not the real performance because we can't measure that yet because the targets are not available. So we estimate it, and that is how we're able to get this view. And we can see here, because the estimated performance is lower than these thresholds, that in those past 3 months, we have some performance issues. As part of this summary overview, we also have multivariate data drift detection. We can add concept shift, or we can add certain features that we know that are important or that we have to keep an eye on, and that when they would also drift, that we would still consider that a proper problem or infringement or an issue, and then we can get them in the summary overview as well. How, again, here on the left side in the UI, we have our performance first approach to monitoring, where we estimate our performance metrics when we cannot measure them. And then only when there is an issue with the performance, we can delve in deeper into these root cause analysis methodologies like concept shift, covariate shift, and data quality checks. And I'm going to actually have a quick look at the performance dashboard. So like I said, our main metric is accuracy, but we can also pick different metrics to have a look on what's going on. And one of these metrics that is truly powerful is the business value metric. We can configure this metric inside of the model settings, and there we can define a cost-benefit matrix. And here we can assign the monetary value that we would get from predicting a true positive, and then also the monetary value that we would lose when, or the opportunity cost that we would have when we make a false negative prediction. And the power of this is that we can connect this cost benefit matrix to our estimated metric, and then we can get a view on the monetary value, and we could know what the expected money is that we would be making in a certain period. And we can see here that even in the second month of production, we would already consider this a loss in business value compared to the reference. So when we've established that there is indeed a problem with the performance, and it's below our defined thresholds, we can then go into root cause analysis. Of course, because we don't have targets, we cannot do concept shift detection yet. I'll revisit this later, but we can go and delve into covariate shifts. And for covariate shift, we provide lots of different ways for exploration. There's distance measures like Wasserstein, there's statistical measures like chi-squared, and then there's also summary statistics that we can apply. I started here with multivariate data drift, which is based on BC8 reconstruction error. And we can see that here in the past 3 months, there is indeed also multivariate data drift detected. And then for the univariate measures, we can select the targets, the model output, the categorical features, and also the continuous features to do some more exploration. But because that's really a lot of data, it's very helpful to only focus on those features that have an alert, and specifically those features that are correlated with a drop in main performance, or that when there is a drop in performance, that it's actually also in that period that we see certain data drift alerts. But for now, I'm just going to pick alerts in the last chunk, and I'm going to do Wasserstein distance, and I'm going to focus on feature drift. So then I will be getting the features that show some data drift in the last few months, in the last chunk. And we can see, for instance, for here, this feature stay in week nights. So, and we can actually see that from the moment this feature, from the moment the model was deployed, this entire feature was drifting the entire time. So probably when we want to go down and do our analysis where we had the performance in the last 3 months, this feature might actually not provide us that much information, because also when the model was performing well, there was some drift in this feature too. So the next step would be to actually, here we can also see because this is a Wasserstein distance, it will also actually give an idea of the magnitude of the drift. But to do the real root cause analysis, we can look at the distributions. This is the average daily rate of the hotel booking rooms. And we can see that here, when there was performance drop, that these distributions were more packed. And we can also actually see that there is some drift in repeated guests and also in the lead time. One of the nice things that we can do here on the left side is that we could also actually look at the average, and then we can look at the line plot again, and then we can see that the lead time, so the amount of time that it takes to do a booking, has actually gone down, and we see actually also lots more of repeated customers. And then when we look at the probability of cancellation, we also see that it has gone up significantly. So these are really the bits and pieces that we can put together as a data scientist to come up with a root cause analysis of what then would actually have led to our models becoming less performant. And that's it for this first analysis on this data set. And I can go back here. And because I added this model via the UI, that is, of course, not the typical way of interacting with a tool like nannyML. Ideally, you would interact with nannyML via the programmatic interface. So we also have an SDK, and I'll quickly walk you through on how to do the exact same thing that we just did, but then via our SDK. And I'll have to quickly fetch the location of where everything is running. And then I also have to create a token. Yeah, don't be copying tokens when you're doing this for real in your scripts. This is just for demo purposes. And then when I'm connected, I'm actually gonna load the data locally. This is the same data set. The only thing that's different is that I will also actually read in the target data. And then again, the same thing, I have to define the model schema where like I said before, that the identifier was index. And it's important because right now we have target data, and this target data has to be connected again to the predictions so that we know which prediction led to which outcome. And the target column is canceled, whether the customers canceled their booking or not. And then we can create the model. And if this is done, then I can have a quick look at the application. And then we can see that right now this new model is added here. And while we're waiting it to be fully run, I can go back and explain how we would typically do continuous monitoring, because uploading data sets like that is more when we do retroactive monitoring, when we do a historical monitoring analysis, when a model has already been in production for a long time. Maybe we didn't have monitoring in the past, and we want to look back and see how that model was performing. But typically with real production, or when we're deploying a machine learning model, we want to do monitoring from the first day. And what we then will be doing is that every time that we make new inferences, we will just send them to nannyML. And there's two ways of sending. We can either send them as batch, where we group all the predictions together and then send them to nannyML, or we can send them single observation after every time there is maybe an API call being made. But it's important to notice that triggering a monitoring run after adding a new instance probably won't have that much impact on the analysis, because most of the metrics are actually aggregated monthly or daily. And then adding one single observation is not going to have an actual impact on the performance metric. But of course, if you want to do real-time or very granular analysis, maybe on an hourly basis, then triggering a monitoring run after adding multiple instances every hour is going to be useful. And here we're, of course, adding just the model input and the output, but there's also part of the API where we can add the target data when it becomes available. Now, I think this has completed running in the meantime. Yes, it has. So right now, this is exact same data. The only difference is that there is target data. And we can see that here right now we have the realized accuracy and also the estimated accuracy in our main dashboard. And I'm quickly actually going to show in the performance dashboard, because then we can compare both. And here we can see how well nannyML did at estimating the accuracy or the main performance metric before. And that's, again, to show how powerful these performance estimation algorithms are when we don't have access to ground truth. Because for here instance, we're predicting whether a customer will cancel their booking in the next 3 months. So we will only know after 3 months, and we would only be able to get a view after 3 months on the performance like this. And right now, because we can estimate it, we already can get it at inference time when we're making the predictions and get an educated guess of what the expected accuracy is. And then when there is an issue, we can delve in deeper and do the root cause analysis like I showed before. Now, because we have targets right now, we can also do concept shift detection, which is a new algorithm in the cloud. And it is, here we can see that there's no concept drift detection. Let's start with that. And the way it goes is that based on the reference, we can see that the concept is pretty stable over time. And that's how we derive these thresholds. If at any given time, actually, you want to change thresholds or you want to do custom thresholds, anywhere in the product, you can configure those. And then you can either do a constant threshold where you define what the definition is of a drop in performance, or you can also do it based on a standard deviation and then set a mean where we would look at the reference. But that's just a tangent. Back to the concept shift detection algorithm. And we would see that here in production, also the concept stays stable over time. And this is an algorithm called reverse concept shift performance impact estimation. So what that means is, it's a mouthful, but we're basically saying what is the impact of the concept shift on performance. And here we're expecting to almost have no impact of concept shift on the performance. If this would be higher, I saw that there indeed here, there was a little bit of something that could be considered a small shift in concept on ROC AUC metric. And then that would mean that the actual ROC AUC led to a minus 0.4, very small decrease in ROC AUC due to potential concept drift. But since for this metric, it's rather stable, that would not be thrown as a concept drift alert. And how this reverse concept shift detection work is that every chunk of analysis, we would fit a new machine learning model, a new concept, and then we would make predictions on the reference data. So with this model, we make predictions, and then with this model, we make predictions, and then we compare those predictions, and we see whether those models on holdout data deliver different outcomes. And that's why it's called reversed, because typically we fit all of our algorithms on the reference, and then we make predictions or we do analysis on the production data. And right now, it's the other way around. So I hope I've given you a little bit of an overview here of how nannyML Cloud works, and that you're fully set up to be able to do a trial yourself without any friction. And again, the main difference between nannyML Cloud and nannyML open source is that in nannyML Cloud, we have more and better algorithms. And then, of course, there's a full-fledged application behind it that does the data collection, that spins up the resources, that does data storage, that sends alerts. And in the open source, it's just a set of algorithms and some visualization.